So I've got a two-stage gear pump, typical of a small log splitter. This one would be something you would find maybe on a 22-ton log splitter powered by a small four-stroke gasoline engine, typical of the kind you might find at a hardware store or rent for the day. The pump is a little more sophisticated than some gear pumps found on hydraulic systems because it is a two-stage gear pump. It's got two different sets of gears doing the pumping inside. They're in a common housing when it's assembled, but you can see there's a seam in the housing. The small gear section, the narrow gears, live in this side of the housing, and that's where the discharge line would connect and take the oil to the DCV to control the cylinder. Here's this inlet coming in from the hydraulic tank. So the suction comes in here and feeds both pump sections, and the wide gears live in this center part of the housing. There's a check valve under this plug that will combine the flows from both the wide and narrow gear sections and combine the flow out the one common hose to the DCV. That'll happen at lower loads and lower pressures. At higher pressures, we'll only get the flow out of the pump from the narrow gear section. So this pump is capable of putting out about, at 4,000 RPM, which is what our little four-stroke gas engines typically are governed to as a maximum RPM on these log splitters. Both pumps together combined will give us about 14 gallons a minute. And about 10 gallons a minute, this is approximate, but about 10 gallons a minute is coming from the wide gears, and about 4 gallons a minute is coming from the narrow gears. They're driven on the same shaft, so they're turning at the same speed, and they always turn together. And the gears are dimensionally the same except for the width. You can see the width here is a little more than double on the wide gears than it is on the narrow gears. So we're getting, again, about 4 gallons a minute at high RPM out of this gear pump section, about 10 gallons a minute out of this gear pump section. There's a pin that drives the small gear set, and the large volume gears are pinned onto the shaft as well in this particular pump. So drive power comes in here. This is the drive end that attaches to the engine, where there's typically a keyway and a key on the shaft with a coupler, and it's driving in and turning large volume gears and the small volume gears. And these are basically low pressure. This is a low pressure pump section only. This is a high pressure pump section, and in reality both pump sections combine at low pressure. At high pressure, this pump is only delivering oil from the smaller gears. And that's done on a log splitter, so you can have a lot of flow if you're splitting soft wood or just retracting the cylinder or working at low pressure situations. You're going to want a lot of speed out of the hydraulic cylinder, so we're going to get that full 14 gallons a minute. You can't have the 14 gallons a minute though at high pressure. The relief valve on these log splitters is typically set somewhere around 3,500 psi, and if you tried to have 14 gallons a minute and 3,500 psi, if I did the math on that, I'd find I need about a 30 horsepower engine. And typically this size log splitter, this is off a 22-ton log splitter, typically they will only have maybe a 8 or 9 horsepower engine. So you can have high flow at low pressure, you can have low flow at high pressure. You can't have high flow at high pressure. You just don't have the torque from the engine to supply that type of effort into the pump. So the way this pump controls the flow rate is through this valve here that screws into the housing. Here, this is called an unloading valve. And the unloading valve is always sensing the discharge pressure out of the pump right from this port. And what it'll do is when the pressure gets over the setting of this valve, factory setting is usually around 700 psi. So as the pressure builds, because you're splitting some harder wood, that pressure will be sensed through this load sensing pin. And the pin then will push down on that unloading valve, and when that unloading valve moves, it opens a passage here in the drive end housing between the discharge side of the large volume gears back to the suction side of the large volume gears. So at low pressure, this unloading valve is in there blocking the connection between these two ports. At high pressure, this unloading valve is pushed open by the load sense pin, and it combines these two connections, or makes this connection between these two ports. And that way all the flow from the large volume gears, instead of combining with the small volume flow and going out the discharge port, it will take the path of least resistance, which will be right back to the suction side of the pump. So that will turn this at higher pressure. Instead of being a 14 gallon per minute pump at high RPM, it'll be basically a 4 gallon per minute pump at high RPM. So the high pressure sealing also, you'll notice, is only on the small gears. We've got thrust plates or wear plates with high pressure seals behind them, only on the small gears. The large volume gears, where they fit in the housing, there's no space or installation of any high pressure sealing, because again, these gears only deliver flow below the setting of the unloading valve, which is typically around 700 psi. So unloading valve again is triggered by the load sense pin, and the way the load sense pin senses pressure from the discharge from this port right through the center housing, from where this O-ring port is, over to this hole, and then from that hole, that's how the oil gets in through there. There's an O-ring missing, but that's how it gets in there to push down on that load sense pin. So the load sense pin is always monitoring oil pressure at the discharge of the pump, and when it goes over 700 or the setting of the unloading valve, it gets rid of that 10 gallon per minute flow from the large volume gears, and it will just circulate around in the housing here. And it's important to note that when that unloading valve is open, these gears are pushing oil around in a loop at essentially no pressure, 0 psi. So that takes all of that horsepower load off of the engine. All the engine has to then input power to is the small gears, which are delivering only 4 gallons a minute, and right up to maybe a main relief of 3,500 psi. And if you do the math on that, that should only require about 8 horsepower from the engine, not 30 if we tried to operate at high pressure with all of the flow. The other component that's in here that is effective with the unloading valve is this combiner check valve. There's just a simple ball and spring in here with a soft seat down inside there, and this ball and spring has to open. The check valve will basically push open against the spring when the large volume gears are going to combine their flow with the small volume gears to give us our high flow output. So at low pressures, that check valve will be open, and oil flowing from the large gears will flow through that check valve across the center section of the housing and combine to go out the discharge. When the unloading valve kicks in at higher pressures, above the setting of the unloading valve, when this opens, that check valve will close, so the small volume gears won't be able to push oil backwards towards the unloading valve and take that path of least resistance. So that closes to force the oil from the small volume gears to always be going out the discharge. So the unloading valve only unloads the large volume gears. So pretty simple pump. Typically cost effective if you're going to put together a log splitter or you're going to service one. These pumps are generally not big ticket items. They're offshore, obviously sourced, and not that many pieces to them, but absolutely imperative that something with a small horsepower engine that's supplying our log splitter for both fast speeds at low pressures and slow speeds at high pressures. You know, the magic of how that's possible to have that machine giving us the different flow and pressure combinations with such a small engine, it has to do with this unloading valve and the capability of this two-stage pump to become a large pump and a small pump effectively in the system. So that's just an overview of the parts inside. I'm going to do another video of the operation of our actual log splitter, and we'll see what making adjustments to that unloading valve actually does. And I'm just going to do a little tutorial here as well on how these parts go back together. This pump is not in any condition to go back into service because it's so many students have had it apart, but just the order of the parts and how things need to be installed. So at the discharge port here, this is obviously where the small volume gears are going to go. We've got high pressure sealing on these thrust plates, wear plates, side plates, whatever term you want to use. Obviously the high pressure sealing is going to keep oil from going from the high pressure side to the low pressure side. So the seals have to face the discharge and they have to go down against the housing. So the soft brass material that looks to be spray welded on this one can be against the gears. And of course, I would want to clean and lubricate all these parts with clean hydraulic fluid. But I'm just doing this for sort of parts installation order. And it looks like we've got that in there a little bit crooked. Get that plate down in there, make sure the seal didn't pop out of the groove. So I've got my one high pressure plate in there. It's a little bit difficult to do this at this trajectory, but I'll see if I can manage this. Then I'm going to start at the other end with putting my shaft through the seal. I'd want to protect the seal from the keyway. But again, this pump's not going back into service, so there's my large volume gears go in here. No high pressure sealing on the large volume section. And I need a little O-ring for that hole, but again, just for the order, this one goes together like this. And if you're going to take one of these apart, you'd want to mark all the housings ahead of time for orientation. And then the unloading valve, I'm just going to install in here where it belongs. And if I had taken this apart, I would count the turns. So when I installed this, I'd be back to the original unloading valve setting, but then the cap that goes on there just locks it to lock the setting. And then I'm going to put the load sensing pin in here where it goes and put the plug in for it. And then the combiner check valve goes in here in the center housing across from the suction port. And then I also need a high pressure sealing plate here. And of course, again, the seals go against the housing, not against the gears. The brass material goes against the gears that are turning at speed. And then I've got a drive pin that, needs to go in here. Sure, that's how the original one got lost. This is just a piece of a hardened roll pin that is in here in place of the original drive pin. And there's the small volume gears, and then the housing goes together this way. And then of course the bolts would have to be installed and torqued. Again, that's just for demonstration purposes. This pump's never going back into service, but that's how the parts install in order to match this one that could be put into service because it's brand new.